So, guys, hello. Welcome again to my lecture. So, today we will be discussing another lesson which is called the center of mass, momentum, impulse, and collision. So, it's a handful of topics, but this is just the four things that we will be discussing for today. This is just the four things. So, let's start off first with our center of mass. Okay, so first off, if you encounter the word center of mass, what comes into your mind? Maybe you are thinking of an object, and then when it comes to center of mass, it is just the center of it. So it is not basically the center per se, but the center on where the object is balanced. Okay, so this is our the gist of this is in a center of mass, the center of gravity acts on where the body of the object balance itself and where the total weight of the body acts upon. Okay, here. Okay, so this is where the body of the object balance itself. Okay? So this example, let's say we have a 12-inch ruler that is balancing on a balance beam. Okay? So that is our the triangle is our balance beam, and it is basically balance. Okay? It's a vertically it is horizontally my bad. It's horizontally balanced. Okay? And what if we put some weights on the end? One small weight and the other one is a big one at the other end. So you think it will be balanced? The answer is no, it won't be balanced at all. So what we're going to do to make it balanced is place our triangle nearer to our bigger object so it will balance itself out. Okay. This is what we call the center of mass. It is not the center of it, but it is where the center or where the balance happens. Okay. So doon nangyayari yung balanse. Kung ililipat natin siya, magkakaroon tayo ng balancing act between the two objects. Okay. So another example here is our this one, balancing bird. Are you familiar with this? Have you seen this one, guys? So this balancing bird balance itself even though it is not uh, the center of its body. So we have here the body of the bird, the first wing, the left wing, and we have here the right wing. So as you can see, they met on that point here on this point here. They met at this point, and this is considered to be the center of the body of the bird, of the eagle. But still, the center of mass acts on the beak or in the head of the eagle, and that is our center of mass. It balances itself. So that is essentially what is the center of mass is about. Balancing the object even though it is not on the center of the body. So normally gymnasts perform this center of mass during their routines. That if you backflip with the center of your mass is your uh, center of mass is your what do you call this one hips or bewang. Uh, the rotation is a little different or a little harder. But if you balance yourself on your center of mass as the center of mass is your chest, then it's a different question. It's a different outcome. So the rotation is also different. So that is what we call the center of mass, where uh, acting of the object that balance itself. Okay, so next is we have momentum. Okay, so momentum is movement of the object wherein mass and velocity is involved. So when we talk about momentum, inertia is involved. So remember our lesson about the mass and inertia. Momentum is an application of the two of them, the mass and the velocity. You cannot have momentum without the other, without one of the two. Okay? You cannot have momentum without mass or without velocity. So both of them are present in the situation. Okay, so when you talk about inertia, normally you will remember the law of inertia on where um, when you break the object or the person, uh, the object at rest will move after the braking of the car. So maybe you are very familiar with that. That's why seat belts were invented. So that is the first inertia experience that we have on our previous lesson. But in here, momentum is acting with velocity. The inertia is acting with the velocity. That's why it is called, momentum is also called inertia in motion. Okay. So inertia in motion. So we have here a formula for our inertia, which is P equivalent to mv. So multiplying mass and velocity, we will be having a unit of kilogram meter per second. Okay, so it is just kilogram meter per second. So that is the unit of our momentum. So remember this formula, P is equals to mv. Okay. So for example, we have here an object and it's having a mass and velocity. So you will see that the object is moving. So this is our usual momentum. An object with mass and velocity is given, or it is handing out momentum. So we have here our velocity, which is 1 meter per second, and we have a mass of 1 kilogram. And so multiplying those two, we will be having a momentum of 1 kilogram meter per second. So that is how momentum works. So now, sir, if we increase the mass, what will be the momentum? Will it be greater? Yes, it will be greater. As you can see, guys, we are traveling at the same speed, which is velocity of meter per second, 1 meter per second, and our mass has increased to 2 kilogram. So we are having a 2 kilogram meter per second. So it is just the momentum, which is equivalent to velocity multiplied to our mass, 2 kilogram mass and 1 meter per second velocity. We will be having a 2 kilogram meter per second momentum. So, sir, another question. If we increase the speed, what will be the velocity? What will be the momentum? So, guys, you can see here that um, the momentum is also increasing. Since we increase our velocity, even though we retain the mass, the momentum is also greater. As you can see, the momentum of our increased velocity to 2 meters per second and our mass of 2 kilograms a while ago, we will both be having the same momentum, which is 2 kilogram meter per second. Okay? And sir, how about this one? We are having objects. Two objects. The one that is um, greater in speed but smaller in size. And we have here another in uh, smaller in size but greater in speed. Okay. So what will happen? So there are two types. There are two things that can happen. The one that is smaller in size and greater in size, but the greater in size has a slower movement, unlike the smaller size. So this is what will happen if the two objects bump into each other, or those two objects collided. so nothing will happen. When they collide, they stop each other. So that is one thing that can happen. So that's one thing that can happen if both of objects produce the same momentum. Okay, if both objects have the same momentum. So we will be discussing this one later in this video. And in this case, we have two objects that bumped into each other and nothing happened. Okay, so this is one thing that can happen. And the other thing that can happen is same. We have the same scenario. We have the same scenario. This one. So they will be just bouncing off on each other. After they bounce off, they part ways. Okay, so this can normally be seen in billiards. Billiard balls bouncing off to each other. This is one example of this kind of momentum collision. Okay, so they bounce off. The first one, they did nothing because they have the same value of the momentum. Now they have the same value as well, but they just bounce off away from each other. Okay, so yeah. So in momentum, as being observed, comes from different shapes and sizes. So momentum can come from a smaller one, smaller in size, or bigger in size. Okay. And momentum only moves in a linear path. So as we saw a while ago, it only moves on a linear path. It can only move on one direction. So secondly, momentum can come from different sizes and speed. Okay, so an example here is a slingshot, a small size object. When it was when if it is thrown, then it can have a great momentum, even though it is small, but the speed is incredible. So the momentum can be great as well. Okay, so another thing is military tank. Even though they move slowly, when they move, everything that is on their way will be crushed. Okay, so that is the essence of having a momentum that is greater in size but slower in speed, and another one is greater in speed but smaller in size. So it can momentum can be created even though it is slower or it is smaller in size. Okay. So we have here another thing is impulse. So impulse is the product of the force and time. So force multiplied to time is the change in is known as the change in momentum. Okay, so it can also be the formula can also be used as mass times velocity, but the velocity here is the final minus the initial. So we have here the same unit, which is uh, Newton second, or still kilogram meter per second. So if you're going to manipulate this one, so Newton second. Okay, so Newton has a kilogram meter per second square uh unit. Okay, which is the uh no, not per. Let me uh delete this one. Erase. Okay. So we have here Newton second. Okay. Newton is kilogram times meter per second square multiplied to second. Cancel this one. We will be having kilogram meter per second unit. So still we can use the unit of kilogram meter per second in our impulse. Okay, so in our impulse, so we can use this unit as well. We can use the Newton second, and we can also use kilogram times meter per second. Okay, so let's proceed in our we can proceed in our next agenda, which is the impulse. Okay, so the impulse is a when a momentum is moving in only one direction. And if you want to change the momentum or the direction of the object, impulse should be applied. Okay, so for example, a bullet that one is too small. Okay, that one is too small, and if you want to change the course of the bullet, what are you going to do? If you touch it with your hands with a minimum contact or with a minimum force applied, nothing will happen. Baka masaktan ka lang or masugatan ka pa. So that is this is where the impulse uh, will be introduced. Okay, so when we talk about impulse, if you want to change the course of the bullet, the same amount of force and the same amount of momentum should be applied in order to change its course. Okay, it's in order to change its course. For example, this one. Okay, so we have here we have this video. As you can see, both of these have the same values. Okay, so both of these has the same values in terms of speed and in terms of mass. Okay, and also their momentum is also in the same value, which is 0.4 kilogram meter per second. So as you can see, both of these object when they collide, they bounce off, they change their direction. Okay, they change their direction. So this is what impulse is. Okay, so they change their direction when the same amount of momentum is applied to it. Okay, so they will change their direction. So another example is here. So we have the blue one as the main object, and if you want to change the course of it, you can apply value of the same momentum, or a greater value of um, our impulse. Okay, so in order for us to change the direction of our main object, that blue one. Okay, so this is another example. So yeah, as you can see, if you want to change the course of the ball, so you have to apply a greater or a greater momentum to the other. So if you want to change the direction, okay, so that is impulse. So if you are going to apply it on a daily basis, well, you will find that momentum at a greater scale can only be seen on a greater laboratory, on a bigger laboratory that can cater all of our needs in our what do you call this one, in our um, simulation. So this is just a small scale. That's why I'm just giving you the hint or gist of our visualization. So yun, if your momentum is great, is incredible, like the bullet, it has a great momentum though, guys. Even though it's small size, you cannot catch it. You cannot catch it. That's why you will be applying the same value of our the momentum or the value of the bullet that is uh that is showcasing or exerting. So you have to give the same amount of momentum or impulse for the bullet to be catch, or for the bullet to be held or to change its course. Okay. So yun. So collision. So for collision, collision is the effect of the momentum of the other body. It is also the event of objects colliding, and it is classified into two. So collision is the effect of momentum to the other body. So for example, a while ago about our momentum, the two objects, the small one and the big one, uh, there is a collision. They collide, and once they collide, uh, there will be two result that will be happening when two objects collide. So it can be elastic collision or inelastic collision. So first, we have the elastic collision. In the elastic collision, the kinetic energy will not be lost, meaning the kinetic energy of the two bodies will remain equal or the same. The objects after collision will have the same mass, but the directions will change. So meaning after the collision, the mass of the objects will be the same, but the directions will be changed. So for example, here. Okay, so just watch this one, guys. So okay. So guys, as you can see, the mass of the objects from the start is this one. 2 kilogram and 1.5. So 2 kilogram is this one and 1.5 is this one. Okay. Their velocity, however, change. Okay. Their velocity change and also their momentum. Okay, so let's play it one more time. Okay, so let's play it one more time. As you can see, guys, here, we have an initial velocity of 0.30 meters per second. We have still the initial mass of 2 and 1.5. And we have momentum of 0.6 for the greater object and 0.45 for the smaller object. So, okay. What will happen? This is the elastic collision. After they collide, after they collide, you can see that the object 1, still the mass is 2 kilogram and the object 2 still has the mass of 1.5. So their mass didn't change. However, their velocity changes. The greater object has a slower velocity and also a smaller momentum. However, on the other end, which is the second ball, we have 0.39 meters per second. The velocity increases. The velocity increases and also the uh, momentum. So this one has a zero point 0.6 momentum a while ago. Now, the second object has 0.58, which is it increases. Okay, so its mass didn't increase, but the velocity increases. So meaning the velocity changes. Okay, the velocity changes, and if it change, the momentum will be greater in value. Okay, so that is our elastic collision. So, sir, why is it called elastic? When we talk about elastic collision, um, the objects tend to change directions once they collided. Okay, so as you can see here, the blue arrows is considered the direction of our momentum, So let's try to watch it again. Uh-huh. Okay, so let's try to watch it again. Okay, so you will see that after they collide, the direction of the momentum change. Yo, you see there, guys? Let's try to look at it again. So they are both going on a different direction but colliding to each other. And once they collided, their change in direction. Yo, you see this one? The change in momentum was visible. Since they will be going on a different directions, you will see that the directions of the ball will be changed from our initial. Okay, so that is our um, change in momentum. Okay, that is the change in our momentum. Okay, so for the next thing is we have the inelastic collision. So when we talk about inelastic collision, if the elastic collision tends to change directions in elastic collision, there will be change of direction also. But you will see what I'm trying to say about change in direction too. So in contrast to the elastic collision, the kinetic energy is not conserved. So for the inelastic collision, after the collision, the objects will stick to each other and move going to the same direction. Okay, so you said that there will be change in direction. Yes, there will be change in direction in one of the objects because they will be both stuck to each other. Okay, so first, before I forget, so you will normally notice this change in momentum or change in directions of momentum in normally in billiard ball. So when they collided, they change or they scatter or they move on to the next location or they move on to another direction. So that is our the change in momentum once they collided. But this one in elastic collision, in inelastic collision, the normal example here are this is just a little brutal, but the car collisions. Normally, the car collisions. Normally, when they collided, they tend to bring the other car. So if there will be two cars, the one that is moving faster and the other one is moving slowly. When they collide, the faster one tends to have the greater momentum, and just like that, the greater value of momentum will just carry out the lesser value. Okay, so this is an example. This is the usual example of inelastic collision. So you see, guys, um, there is a they stick together and they move on to the same direction. So let's try to watch it again. So here is it. Yeah. So you can see the first object has a momentum going to the right and the other object has a momentum going to the left. But the mass of our first ball is having a greater mass or uh, double its mass, double the mass of our second ball. Okay. So with this, they will be having a greater momentum. The ball one has a greater momentum than the ball two. Okay. So what will happen next? What will happen next is that object one tends to bring object two to the same direction. Okay. They both move to the same direction. So you will see, guys, that they will be both having the same They will be both having the same velocity. Okay, which is 0.33 meters per second for mass 1 and mass 2. But their momentum will be different, which is 0.5 kilogram meter per second mass for ball 1 and 0.25 kilogram meter per second mass for ball 2. Okay, but their mass will still be the same. Nothing had changes. Okay? Okay. So let's move on to the next example of inelastic collision. So sir, question, if an inelastic collision has the same value of momentum, what will happen? Same value? Same value. Let's watch this one, guys. Same value of momentum, same mass, same velocity. What will happen when they collide? If it is inelastic, they will be having a breakdown. So they will be stopped at on where they were collided. So this is an example of inelastic collision having the same velocity and having the same mass. Okay, so if it is inelastic, they will be bounce off to each other. Okay, so but still, we're having an example of inelastic collision. So in this case, the two objects after they collide, they will stick to each other. Okay, so that is our inelastic collision. Okay, so next is what's going to happen next, sir. If the first object has a smaller velocity but greater in size, and the other one has greater velocity but lesser in size, what will happen, sir? Okay, so let's watch this one, guys. Ball one has a slower velocity. Okay, so yes, so even though they have different velocities. The first one has 0.3, the other one has 0.4, which is this one's greater. And but the mass but the mass of our ball one has 2 kilogram and our ball 2 has 1.5. So they will be having the same momentum even though they have different size and different speed. Okay, so what will happen is they will be they will be having a stoppage also. They will stop because of having the same momentum. Okay, so if they have the same momentum in an inelastic collision, they will both stop. Okay, so next, sir, is this one. So, sir, the question here is one is greater in momentum, greater in size, even though they have the same speed. What will happen? Okay, so if they have the same speed, but the other one has a bigger mass, what will happen? So this one will happen. So they will be both carried out on on the same direction. Okay, so as you can see, they are both now traveling to the right, even though they start moving on to different directions. They end up moving, going to the right. Okay, so they will be having the change in momentum. They will be having change in direction, but the change in direction, as you can see here, guys. Here is it. Okay, so let's watch this one. Okay. Okay. You see, there is a change in direction of momentum. But, sir, they are moving both to the right. Okay, so the change in direction here, the change in direction of momentum is um, this ball one has a greater momentum that even though there will be change in momentum, still he is going on the same direction. Okay, so this is a greater momentum that the other ball cannot stop. Meaning, even though they collide, the greater force, the greater momentum still prevails. Okay. Okay. So next one is, sir, they are moving on to the same direction. So guys, you can see that the velocity is going to the right for ball 1 and the velocity is going to the right also for ball 2. So what will happen if they both have a collision like this one? Okay, so when they collide like this, when they collide like this, so it is basically the ball 1 will drag the second ball on the same direction. So there will be collisions also. This type of collision can normally be seen on traffic jams. So traffic jam. So when if there is a car that is rushing from behind and smashes to the first one on the car that is in front of it, so it will drag out the car that is in front of our subject, which is the faster car from behind. Okay, so they will be dragging out each other. Yeah. So you see, they move on to the right with the same direction. So and the velocity is the same 0.73, 0.73, but the momentum is different. But still, the mass is in constant. So as you can see, mass is repeatedly mentioned here, and still, even though it is repeatedly mentioned, the mass didn't change at all. Okay, so that is our collision. We have also discussed the impulse and the center of mass and the momentum. Okay, so now we will proceed the law of conservation of momentum. Okay, so just like the energy, we have a momentum and we have loss for it. So two objects about to collide, the momentum's magnitude is the same but different in direction. Okay, so they will be moving on about the collision. So they have the momentum's magnitude. Let's say they are the same but different in direction. So as you can see, the net momentum of an individual body of the object before and after an incident is equal. So the net momentum. For example, for from our previous lessons, that you cannot give what you don't have. Okay, so the net momentum has its loss also, that um, uh, you cannot produce a greater momentum if you don't have a great momentum. Okay, so before and after the incident, it is equal. Okay, so momentum change equal magnitude opposite direction. We have m1 delta v1, which is equivalent to negative m2 delta v2. Sir, question, why is there a negative? Okay, so this is just the indication of negative. That this negative sign is the indication of opposite direction. So if this one is going to the right, then the other one is going to the left. So that is just the indication of direction. So we have here mass 1 and delta V1, which is this one. This delta is VF minus VI. Okay? So that is our um, velocity V1, V2. So with this, so the net momentum before is equivalent to net momentum after. Okay, so we have here formula of m1 v1 plus m2 v2, which is equivalent to m1 v1 prime and m plus m2 v2 prime. So this prime indicates that this is after the collision. So based on our videos a while ago, what what can you say about about the videos, guys? So we have our initial mass for ball 1 and ball 2, and we have our initial velocity for ball 1 and ball 2 also. So with this, they are traveling on a different directions, and once they collide, their mass will be the same, meaning nothing changed from their masses. Okay. But with their velocities, as you can see, they are both in prime, v1 and v2, meaning their velocity change from a higher to a lower velocity, or from lower velocity to a higher velocity. There will be change in velocity. That's why we have momentum after the collision, which is known as v1 prime or v2 prime. Okay, so mass is constant. Okay, so let's try having this example. Okay, so example one, momentum, a car weighing 1,000 kilograms traveling at a speed of 5 meters per second. Solve for the momentum of the car. So this is just the momentum. So we have here given of 1,000 kilograms and velocity of 5 meters per second. Using the formula P is equals to mv, 1,000 kilograms multiplied to 5 meters per second velocity, we will be having a unit, a 5,000 kilogram meter per second uh, momentum. So let's try this one. 1,000 multiplied 5 will result to 5,000 momentum. Okay? So try to copy this one, and we will be moving on uh, to the next example. Okay? Okay, so let's move on to the next example. So for the next example is a car weighing 1,000 kilograms running at 20 meters per second got a head-to-head collision with a truck slowly running at 5 meters per second and weighs 2,000 kilograms and the 5 kilos baggage. After colliding to each other, the car and the truck moves backward. The car and the truck moves backward and the truck's movement has been cut into half. Solve for the speed of the car after it collided with the truck. So now we will be applying the law of conservation of momentum. So please try to solve this one, guys, and let's uh, and we will be discussing this one after you try to solve this one. So I'll be giving you time, guys, to solve this one. Okay, so please try to solve. Okay, so here is the solution. For the given, we have mass of the car, which is 1,000 kilograms, and the mass of the truck, which is 2,500, for the reason that there is another 500 kilos of baggage for it. So the velocity of the car pre-collision, we have 20 meters per second, and the velocity of the truck, which is 5 meters per second. So they move backwards after, and then the velocity of the truck will be cut into half, which is negative 2.5 meters per second. Again, the velocity, the negative sign only indicates the direction. So we will be looking for the velocity of the car, which is v1 prime. Okay, so we will be using the formula of m1 v1 plus m2 v2, which is equivalent to m1 v1 prime plus m2 v2 prime. So substituting the values we have here for our car 1020, we have 2505 for the truck. So we have the same mass for our car, which is 1000, but we have a missing of 1000 of velocity. And now the mass of the truck still is the same, and negative velocity for our movement. So we have a value of v1 prime, which is 26 negative 26.25. So let's try to solve this one, guys. So here goes. Okay, so we have 1,000 multiplied to 20, and addition of uh, 2,500 and 5, which is equivalent to 1,000 multiplied to our unknown, and we have 2,500 for the truck and negative 2.5. So what will be the answer? The answer is 38.75. Oh, so how did that happen, and why do I have the answer of uh why do I have the answer of negative 26.25? So let's try to see where did I get wrong. Okay, so I guess, okay, so let's try this one. Am I wrong? Is there anything wrong I did? So it's 1020, and we have 2500 multiplied to 5, and we have 1000 multiplied to our x unknown, and we have 2500 mass, and negative 2.5 cut into half. So let's try to solve this one. And okay, so I guess there's a typographical error in this presentation. So we will be having a value of 38.75. So this is the good thing about this one, that this presentation has its flaws, and the good thing about this is we are solving it, and that's why we can see what did go wrong on this presentation. Okay, so this is it. We have the answer of 38.75 meters per second. Okay, so okay, so now let's move on to the next. We have inelastic collision. In the previous problem, the car and the truck collided elastically using the same givens before the collision. Solve for the velocity of the inelastic collision. Okay, so guys, please try to solve this one. Okay, so we have here the mass of the trucks. Still, we have the same values, and now since it is inelastic, they will be both staking, and they will be having the combined value of 1,000 plus 1,000 plus 200. Okay, so let's try this one. Okay. So if they will be sticking out, then we will be having this 1,000 plus 2,500 multiplied to our x. Okay, so solution is we have 9.3. Okay, so as you can see, guys, we have the same value. So a while ago, I just committed um, the typographical error. So we can see that this formula has the same value as our uh, computed value. Okay, so that's it, guys. So if you have any questions, just raise your hands, and I will be gladly calling you out if you have any questions. So that's it for today, guys. So thank you. God bless. Peace out. Stay safe and ingat.